Nice, sir.
Nice. Useful?
Yes.
Great.
Sir, I think you were saying that there'll be an assignment on the portal. There was
Yeah,
sent.
yeah, yeah. Today I'll be sending you one assignment after my class.
Okay, sir.
Right? You will get it. Okay, Mayan, Saksham, all of you please turn on your video.
Yes, sir.
Turn on video, please. Hmm. Hmm. Okay, let us start with one experiment. As usual, every time we start with one experiment. Right?
Yes, sir.
Uh, do you have hard surface on in front of you or somewhere nearby? Hard
Yes,
surface.
sir.
Okay. It must be like your table. It may be your table,
Yes, sir.
right? It may be wall nearby.
Yes, sir.
Okay. Now, if you hit that hard surface with your fist, what do you feel? What is your observation? Saksham.
So can you repeat?
Yes.
Can you repeat, sir?
My question is, if you have some hard surface nearby, like maybe wall, maybe hard table, maybe anything that is a hard surface, and you hit it with a fist like this, like this. I'm hitting my table. What will you feel?
I don't feel anything.
You will not feel anything. First,
I tried. I'm not feeling anything.
you're not feeling anything. Okay.
So if we hit a hard surface, then surely our hand is going to pain.
That also depends on the force, amount of force you apply.
Yeah.
If you
Okay.
apply more force, you will get it more.
Okay. If you apply more force, you will be hurt more, right?
Yeah.
Okay.
And I think this is because
Yes,
of
sir.
Newton's third law of motion.
It's a third law of motion. Good. Okay. Third law of motion. It's a Newton's third law of motion, right?
Yeah.
Right. Okay. Can you give any other example or can you demonstrate with any such type of experiment the third law of motion?
Yeah.
Yeah, please.
So there's when a boatman wants to push the boat away from the shore, he pushes the shore with the oar, right?
Hmm.
And then it applies an equal force on the boat. So that's why the boat pushes away to the water.
Right. Okay. Good example. Any other example? Sparsh.
So it can be, for example, like if we take a wall, if there is a building, then if we try to push that, we will come back because of the third law.
Okay. Saksham. Any other idea?
So, like, suppose, yeah, the recoil of the, like when you're shooting a gun.
Good. Good example. Recoiling of your gun, right? When you're shooting, you feel the pressure on your shoulder. Have you ever experienced this? Have you ever tried this? Yeah. Okay.
So
No,
I got to know there
I
is an
haven't.
example even of swimming that when we are pushing the water backwards, but we are going forward. But an example of the boat,
Yeah.
we move forward, the boat goes back.
It is the same that Mayan has explained with the boat, and you had used swimming. Basically, the same idea. Okay. I want to. Yes, Arav. Can you tell me some example of Newton's third law? Yes, Arav. Can you hear me?
I forgot.
No.
I don't remember.
Okay. Okay. What about upthrust of a rocket?
Yeah,
upthrust,
that's an example of
Yeah, that's
Newton's
also
third law of motion.
right? Upthrust of the rocket. That's also based upon a third law, yes or no?
Yes,
Yeah.
sir.
Okay. So I'm going to make a rocket with a balloon to demonstrate the law of Newton's third law. Okay. So I'm sharing my screen.
so we can just fill up the balloon and leave it. We'll just
Okay. You fill the balloon with air and release it. The balloon will go this way. The air will come by the back.
Yes, sir.
Right? Yeah. Again, that I have designed an experiment as an air balloon rocket. It is a balloon rocket. Can you see my screen?
Yes, sir.
Yes, sir.
So, how I had designed, you can note it down, you can take the screenshot, later you can play with it. That will be better to understand the concept of Newton's third law. Right?
Yes, sir.
You need a balloon, a straw, thread, and clear tape. Okay. Note it down.
Done.
Tie in one end of the thread to a steady handle. Secure it with a couple of knots. Basically, you have to tie a thread with something stable, steady handle. Then pass the other end of the thread through the straw as shown. Pass the other end of the thread thrown through the straw as shown. You can pass the thread. Now blow a balloon and hold its mouth with the fingertips. Okay, and
Yes, sir.
stick to the straw using the tape. Keep holding the mouth of the balloon. Okay, and then you can release it. Release the balloon. The air will go this way. The balloon will go opposite to the direction of the throat of the air. Understood?
Yes, sir.
If the air goes towards this student, then the balloon will go opposite to the flow of the air. Am I clear?
Yes.
All right.
So I didn't get what's the point of like the straw and all.
Straw will move on the thread.
Yeah. Because
The-
of the balloon, the straw will move.
yeah, but actually balloon will push it actually.
The
And
balloon is like the source of it.
yes, balloon will become
Yeah.
the source of the thrust pressure. Getting me?
Yes.
So that's how you
Yes,
can
sir.
make a rocket balloon. It is based upon the third law of motion that for every action there is equal and opposite reaction. Here, the propelling jet of the air from the mouth of the mix balloon propagate with an equal and opposite force of direction.
Yes, sir.
Understood? Now, try sticking two equal balloons, head on the same straw, release them simultaneously. One will go toward the left hand, other will go toward the right hand side. Now, in which direction it will move now?
So the balloon that's going to have,
because
They it'll be
because
so
hitting.
they're
it will
both
stay at the
equal
same
now today.
position.
If the pressure of the balloon is equal in all, the straw will not move, right?
Yeah, it won't move.
Yeah. So equal and opposite forces cancel each other. Equal and opposite forces cancel each other. You got it? So, okay.
So, but this was physics. Was there any use of chemistry in it?
Okay. I'm coming to the chemistry part then. Actually, the chemistry behind this is now I'm filling these balloons one time only with the air, another with the hydrogen gas, another with the argon gas, then with the chlorine gas. If I fill different gases, the speed of the balloon, will it be affected by that?
Yes, sir.
Yes. There comes the chemistry, right? I'll come to that chemistry later. That if it's not a physics actually, see, understand that this physics, chemistry, biology, and mathematics at later stage all become one. Means if you are learning physics, chemistry will be part of it, biology will be part of it, and mathematics will also part of it. Right? If you're learning mathematics only, it is not just mathematics, it will also include the physics and chemistry also. So basically, you have to understand the scientific temperament. And then I'm connecting this experiment of science. I will not say of the physics, I'll say it is of science. You can apply it in the biology, you can apply it in the chemistry, you can apply it in mathematics also. Now, if I say, okay, I'm stopping this and then I'll talk to you. Right. You can turn on videos, right? How we apply this science in biology, this physics in biology, or in chemistry, right? The same experiment, right? Now, what you do is you just open your mouth and feel that warmth of your breath. Can you do it? Do it now. Do it now. It's a hot air or cold air?
Hot.
It's hot air, right? How much
That's right.
hot? How much hot? It's equal to the temperature of your lungs. Yes or no? The same with the temperature of your lungs. That's the temperature that is coming in the air. But now what you do is you blow air forcefully by the small mouth, small opening of the mouth. It's a hot or cold. Do it. Do it. Why don't you try it? Do it now.
Shall be cold.
Sir, it's like cold.
It is cold now. Same air, when it is blown with less pressure, it is hot, but with more pressure with a small pore, right? Small opening, it is becoming cold. Why it is so? Good question, right? Air is same, mouth is same, lungs are same. I have not changed anything, but only pressure we have changed. Why it is so? What do you think, Saksham?
Sir, can you repeat, sir?
Okay. Nipon, you do have to do two experiments with me now to understand my question. Open your mouth wide and blow air outside like this and feel the heat of feel the temperature of your air. It's hot or cold?
So it's hot.
It's hot. It's the temperature of the air that is of your lungs, right? Now, if you blow here with a small opening of your mouth with a force like this, it's hot or cold.
So it's cold.
My question is why? Your lungs are same, your air is same, your hand is also same. Why do you feel the difference?
So maybe
So maybe because of
so
pressure.
What is the effect of the pressure on this?
so when you're when you said blowing with a wide mouth, it's more like exhaling. That's why it's warmer. And when you blow with the small clap, it's more like just right.
So maybe because when we open the big mouth, the air is like still compressed, I think, and it has the same temperature as it's coming from the lungs. But when our mouth is less open, then it's less compressed, and hence
What is the effect of the
more temperature.
pressure? What is the effect of the pressure on temperature now? How?
When pressure increases, boiling point increases.
But we are not boiling anything, right? Okay, okay, understand now. Understand. It's very simple to understand. Arav, it is possible, then you can turn on video also. Okay, now understand. Uh, I'll share my screen here to make it more clear. Can you see my screen? Black color screen?
Yes, sir.
Right.
Yes.
This is your lung that is filled with air, and this is your wide open mouth. The gas temperature is T. The same temperature comes here. Right? Temperature T. The same temperature comes here. The air is coming out. But now, what you have done, you have made this hole smaller now. Temperature T1, temperature T2, and T2 is less than the T1. The reason behind this is these gas particles which are inside your lungs, they have some intermolecular force of attraction. I'm using a word intermolecular force of attraction. Okay. In some intermolecular force of attraction is there. And this force of attraction, when it comes out in the open atmosphere, the particles move away. It means here they are bonded, here they are compressed, here they are having some intermolecular force of attraction. And when it comes out through a small pore, the particles move away. But to move away, they have to break this intermolecular force of attraction. They're very, very close to, they have to break this bond. Now the particle move up. So some energy is required to break the intermolecular force of attraction. Am I clear?
Yes, sir.
And to break
Yes.
it, we need some energy. To break it, we need some energy. And that energy comes from the kinetic energy of the molecules. Molecules have some kinetic energy, right? And we know that kinetic energy is directly proportional to temperature. Some kinetic energy is used in the separation of these molecules, so the temperature will also decrease, and that is why the temperature here comes down and the air becomes cold.
Yes, sir.
What do you say? It is a part of physics or chemistry? or biology? What do you say?
They're all three.
All the three. Yeah, it's all the three. It includes physics, it includes chemistry, it includes biology, everything. So whenever you're performing an experiment, it must be very clear that we are not doing just chemistry, we are not doing just physics, we are not doing just chemistry, biology, we are doing all together. Everything is happening not just in one subject, it is happening in all the subjects. But our point of view is we're looking in only in chemistry perspective or in terms of mathematics perspective or physics perspective. Clear? So like in the examination like Olympiad, the question will not be of biology or chemistry or biology or physics. It will be of science, that you have to apply all the three fields and then you can give an answer. Understood? Clear?
Yes, sir.
Okay. Now I'm coming to the topic of atomic structure. Atomic structure. Last time we were discussing atomic structure,
Yes.
right? We discussed about different models of an atom. We discussed about Rutherford model. We discussed about J.J. Thomson model. We discussed about
Yes.
radioactivity. We discussed about right, all these things we have discussed. Today, I'm going to give you some practice about some multiple choice questions. Are you ready?
Yes, sir.
Right.
Yes, sir.
So wherever you will be stuck, just let me know. I'll go into detail of it. Otherwise, we'll be keep on answering the question and learning it. Okay. I have this question that I have already discussed the discharge tube experiment.
It's first option.
The first.
First option.
Okay, good. Very factual question, right? We know the experimental setup.
Atom.
Atom.
Everyone clear? Anyone who is not clear, just let me know. Okay.
So it is the
Rutherford. Rutherford.
Good.
Electron.
Electron.
it's an electron.
Good. This I had not taught you, right? Have I taught you E by M value?
No, sir.
No.
No,
I,
sir.
but I think it's the first one. Yeah.
Yeah, it is first one, but not required right now. Leave this part. Okay, now come to this.
Chadwick.
Good.
Chadwick.
Chadwick. Hmm.
3.
Mhm.
Two.
Is it one?
See, it is a protium. It's a deuterium. It's a tritium. This tritium is radioactive.
Yeah, sir. Tritium is radioactive.
This is the atomic number. And this is the mass number, right?
Yeah, so sir,
Mass
I
number,
said two.
protons plus neutrons. 3 atomic number में
Yes,
protons
sir.
is 1 and now neutrons are equal to 2. Getting me?
Yes,
Yes,
sir.
sir. So I said two.
Yeah, it's a 2. Yeah, you're right. Understood?
Yes, sir.
You know this formula now?
Yes.
Yes,
If you
sir.
find any
Yes, sir.
difficulty, just let me know. You can note down the formula. Right, should I go ahead? Agreed now?
Yes, sir. Good. Go
Okay.
ahead.
Yes.
3:7.
3:7.
Yeah.
Everyone clear?
Yes, sir.
Anyone who is not confident about this? Can you explain me why?
So who will explain?
Yeah, you tell me. Saksham?
So this is mine.
Mm-hmm. You know it? If it, yes, you tell me.
Okay, so the atomic number of carbon is 6, and the atomic number is equal to the number of protons. The
Mm-hmm.
mass number is equal to number of protons plus number of neutrons. So 12 minus 6 is equal to the number of neutrons, which is 6.
Mm-hmm.
The same thing for silicon also. Its atomic number is 14. So the number of neutrons must also be 14. And then so 6 is to 14. So if you cancel that out, it'll become 3 is to 7.
Good. This way. Yes, Nipun, are you getting this?
Yes, sir.
Right. Everybody confident about this? Clear?
Yes, sir.
Good. Hmm.
C12.
Good. Hmm.
Twenty.
54.
That's
Oh,
20.
yes.
20.
Chlorine atomic number 17, mass number 37, neutron will be equal to 20. Right? Everyone
Yeah.
clear?
Yes, sir.
All right. This equation not required. Work upon this.
8. 7 protons and 10 electrons.
7 protons and 10
10
electrons. You are
electrons.
right. Everybody clear or you need my explanation? Sparsh,
So I need an explanation.
you need. See, when I say lithium nitride, it means I have a 3 lithium ions and 1 nitride ion. You got this?
Yes, sir.
Okay. Nitride ion means in the nitrogen I have added 3 electrons.
Yes, sir.
Atomic number is 7, mass number is 14, and charge is 3 negative. Atomic number 7 means I have a 7 protons. Right? I have 7 protons.
Protons.
So electron in a neutral atom will be equal to 7, but I have gained 3 more electrons. So electrons will be 10. In a neutral
Yes, sir.
atom, there are 7 protons, there should 7 electrons are there. But in case of nitride ion, the electron will be 10 plus. So 10 plus. So 7 protons and 10 electrons.
Yes, sir.
Protons and neutrons.
Protons and neutrons. So protons and
Protons and
neutrons.
neutrons.
Nucleus contains protons and
Neutrons.
neutrons. Yeah. Straight, if you find any difficulty, just let me know. Right? It is not a fact base or something. You have understood it. Okay, now. Z is the atomic
It's
number.
M.
Z is the atomic
M.
number. Yeah.
M minus.
It's M.
So not sure.
The number of the nucleons in an atom are.
M.
Yeah, we are representing like this. Actually, we can represent like this: atomic number, mass number. In the mass number, we have a protons and neutrons both.
Yes, sir.
Okay.
Mass number.
Good.
So I don't know.
Isoelectronic. Now understand the concept of the isoelectronic. Isoelectronic means same number of electrons. If I say CO, 6 electrons of the carbon and 8 electrons of oxygen, total we have 14 electrons. Total we have 14 electrons. Is that clear? Now
Yes.
calculate the Cn negative ion. 6 electron carbon, 7 electron nitrogen, 1 negative charge. Again, there are 14 electrons. OH negative ion, 8 electron oxygen, 1 electron nitrogen, 1 negative charge is equal to 10 electrons. Got it?
Yes.
Nitrogen
Yes,
2, nitrogen 7 plus 7 minus 1 because I had taken 1 electron out. 13 electrons are there. Oxygen are 8 electron, 1 extra electron, that is equal to 17 electrons. And isoelectronics are those in which the number of electrons are same. So I can say this is the same electron. The answer should be equal to 1.
Okay, sir.
Understood?
Yes, sir.
Everyone clear?
yes, sir.
Isoelectronic means same number of electrons. Those species which have same number of electrons. Now, this question you can leave. Okay, come to this question now.
18.
18, the number of electrons. Atomic number 18. Atomic number is 18. Atomic weights are 38 here.
Yeah, so the number of electrons is 18 if it's like a neutral
Yeah,
atom.
protons are same.
Protons are also 18.
Yeah. So it should be
But
18.
this is only if it's a neutral atom.
Of course, neutral atom. It's a neutral. 2 atoms are given. They are not saying the ions are there. These are not ions. These are atoms only. Atom means neutral atom. Okay.
Fourth one, sulfide ion.
Isoelectronic species that has relatively more protons. More protons.
Oh, no, it's relatively more than protons.
More than protons. Yeah. Okay. Electrons are relatively more than protons. Yeah. Good. So what is the answer now?
Fourth one.
Fourth option. Sulfur atomic number 16. Mass number 32. Protons are 16 but electrons are 18. Right?
Yeah.
So it is the fourth option correct answer. Understood, everyone?
Yes.
Students, you can take the screenshot if you wish. You can note down. You can.
Sir, could you please send this in the app also? This like PPT, whatever it is.
I
Is
will
it
do it.
possible?
I will do it. I will do it.
Okay, sir.
I will do it. But some questions are of the above level that I'm skipping. You can skip that.
Okay, sir.
Right? Do you know this mole? Have you done that mole concept before? No, I don't think you're done.
No, sir.
Okay, I'm leaving this question for some time. Leave it. Come to this question.
Uh, 21. 21.
Okay, X and Y are isobar.
Yes, sir. 21.
You know the meaning of isobar?
Yes, sir.
Isobar are having the same mass number, right?
Yes.
So X and Y are having the same mass number. X has 19 proton, Y has 20 protons. Okay, the number of neutrons in X is equal to. You tell me.
In what? Y or X?
In X. Question is Y.
It's 21.
21. Good.
Rutherford.
Yes, I
Good. No, electrons. Rather, the most right now you can leave that question. Okay, so here's the question. The number of electrons in this.
I think this is the fourth one. Yeah, fourth one.
No. See, electron charge and the proton charge is equal.
Yes.
In case of sodium positive, I have 11 protons but 10 electrons. And the 10 electron neutralizes the remaining 10 proton. I have only one extra proton. Can I say that?
Yes.
It means the charge of the electron is equal to charge of the proton. So that will be equal to option 1.
Yes, sir.
Yes. Sir.
Yeah. Faraday, I had not told you, right? I had not forwarded. I had not taught you the mole concept, so I will not take up this one. Leave this question. Yeah, work upon this question.
Is it 12?
Repeat
12.
with option 4.
Yes, sir.
Let us check it. An atom A, mass number 2Z plus 12, where Z is the extra nuclear electrons in an atom. That will also be its atomic number, Z.
It will be Z plus 12.
So the number of neutrons will be equal to 2Z plus 12 is equal to the mass number, right? 2Z plus 1.
Yes.
And so how much will be the Z plus 10? That is the mass number. And from the mass number, if I subtract the mass number is equal to 2Z plus 12, that is already given. So
Minus Z.
minus Z, yes. Decrease the number of protons there.
So it will be Z plus
Z
12.
plus 12, yeah. Got it?
Yes, sir. I got it.
Everyone? Arav?
Yes.
Arav, are you getting this?
Yes, sir.
Right.
Goldstein.
Yes?
Goldstein.
Goldstein, yeah. E. Goldstein. Leave this part. I have not discussed this. Yeah.
Is it the third one?
Yeah.
Okay.
Everybody getting me or should I explain?
So please explain this.
So what is HD ion? Because I don't think
Yeah.
we've done
Yeah.
So
this.
could you please explain this?
I'll explain.
I knew that option 1 and 4 wasn't there because
I'll tell
in
you.
one.
I'll tell you. I have stopped sharing for some time. Wait. You can see my screen?
Yes.
Okay.
Yes, sir.
If I say H atom only, I can say one proton, one electron, but neutron 0. Yes or no?
Is Hd ion like
No. First
deuterium ion?
First understand this. Yes or no? Only I'm talking about H atom.
Yes.
If I say a 1H2, 1H2 means deuterium. Deuterium,
Yes, sir.
right? Deuterium. Here the protons are 1, electrons are 1, but neutrons are 1. You got it? That is why the mass number is 2.
Yes.
I have 1H3. That is called a tritium. T, deuterium D. Proton 1, electron 1, but neutron 2. Yes or no?
Yes.
Yes, sir.
Okay. Now, I'm talking about H2 molecule. I have here 2 protons, 2 electrons, 2 neutrons 0. I have 2 hydrogen atoms basically. Understood? One proton of this, one
Yes.
proton of this, one electron of this, one electron of this, but neutrons are 0. Okay.
Yes, sir.
Now, if I say HD, D for deuterium, protons are 1, 1, electrons are 1, 1, neutrons are 0, 1. Got it? So, protons are equal to 1, 1 plus 1, 2, electrons are equal to 2, neutrons are equal to 1. Yes or no?
Yes, sir.
Yes, sir.
Now, if I say I have HD positive, it means I had taken 1 electron. This
Sir, but what is D?
D for deuterium.
Okay, sir.
So, I have removed 1 electron now. Left with one thing only. Not clear.
I got it.
Yes.
Saksham? Arav?
Yes, sir.
Nipun?
Yes, sir.
Okay. I give you one more question then. I have an HT1 positive. Tell me the number of protons, electrons, and neutrons.
Two protons, one electron, two neutrons.
Protons, 1 from the hydrogen, 1 from the tritium. Electrons, 1, 0, 1. Neutron, 0, plus 2.
Yes, sir.
So I have now 2,
Two
1, 2.
protons,
1
two
electron.
neutrons, and one electron.
Yeah. Got it now?
Yes, sir. Got it.
This is clear now.
Yes, sir.
Mass number.
Mm,
Except chemical
yeah, mass
properties.
number.
Except chemical properties.
Chemical property. The isotopes differ in the chemical property. Differ in all. They will have different mass number, different physical property, different reactive properties. But chemical
So I
property.
didn't know about the radioactive
Exact.
properties.
Okay.
See, if I say I have a protium, that's not radioactive. But if I say tritium, that is radioactive. Both of these are isotopes. This is radioactive.
Because it has.
It is radioactive. It will emit alpha, beta, gamma rays.
Okay, sir. Got it.
Okay, do you know the electronic configuration?
No, sir.
No.
Yes, sir, I know what electronic configuration is.
Wait.
Yes, sir.
Wait.
So can you at least show the question? I want to see if I can answer it.
I'll show you the question, but I will focus upon first electronic configuration. What is it? How it is created?
Basically, the arrangement of
Yeah.
electrons. And there are certain rules for arranging the
Yes.
electrons.
I will tell you. I'm coming to the basically how to make the electronic configuration. I'm stopping sharing for some time. Okay, you have turned off your videos. Turn off. Okay. I will now explain the electronic configuration. How electrons should be arranged around the nucleus. Uh, have you ever participated in a group dance or in a school somewhere? Group dance.
No, sir.
No, all of you scientists don't take part in. Okay, you might have seen a group dance.
Yes.
Yeah, maybe in
Yes.
school, maybe in some TV program, maybe in some song or something. Yes or no? Okay. I give you one typical example of a group dance. Very typical example. If you have seen, have you seen a group dance of a mythological picture, mythological character, Krishna and gopis?
Yes.
Yes, sir.
No.
In the center, the Krishna is there, and then gopis are there in a particular pattern, and they're all
So
dancing.
you're saying Krishna is like the nucleus and the gopis are like the electrons.
Yes, exactly. And now, two gopis are the first circle, 8 gopis in the second circle. Got it? Right? And then all are moving. That arrangement of those gopis around the Krishna is something like the electrons are revolving around the nucleus. The same type of dance you can see in other movies also, where Shah Rukh Khan is in center and some other dancers are around.
Yes, sir.
Yeah, you can exactly the same thing basically. Okay, so there is a to write the electronic configuration, how electrons are evolving around it. I'm directly coming to some conclusion rules that this is the nucleus, and around the nucleus in the first shell there will be 2 electrons. In the second shell there will be 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Again in the third shell 18 electrons will be there.
So, but 18 electrons can only be there if it's not the outermost shell.
Yeah. 2, 8, 8, 18. This is conference. In the third we have again 8. In the fourth we will have 18. Okay.
So
I'm coming to it step by step. And I'm writing electronic configuration. Yes, what do you want to say? You are going to ask something. Tell me.
so for the third one there can be 18, but for the fourth one there should be 8 because it'll be the outermost one.
Let us see. Because hydrogen, atomic number 1,
Yes, sir.
nucleus. I have only 1 electron, so I'll make it only 1 electron. So I'll say the electronic configuration is only 1. 1 means the shell number 1, it is only 1 electron. Helium.
Yes, sir.
Helium, atomic number 2, mass number 4, right?
Yes, sir.
When the protons are 2, the electrons are also equal to 2. Nucleus here, and around the nucleus in the first shell there will be 2 electrons. So electronic configuration is, in the first shell we have 2 electrons. Understood?
Yes, sir.
Lithium, atomic number 3, mass number 7. It means I have 3 electrons. In the first shell I can fill maximum 2 electrons. In the second shell I can fill 8 electrons, but now I will have only 1. So this is the electronic configuration. Means in the first shell I can have these 2 electrons. In the second shell I can fill maximum 8, but only 1, because I have in total 3 electrons. So the electronic configuration is now 2 1. Yes or no?
Yes,
Beryllium, atomic number 4, mass number 9. I have 4 electrons. It means in the first shell I can have 2 electrons maximum. In the second I can have maximum 8, but I'm left with only 2 more. So I have electronic configuration 2 2.
Yes, sir.
yes, sir.
Understood?
Got it, sir.
Right. Can you write up to 10? Atomic number 10, atomic number 5, 6, 7, 8, 9, 10.
Yes, sir.
Okay, try
I
it.
can
Yes,
write
sir.
Try
20
it.
also.
I'll be back in a minute only. You try this thing.
We're done.
Just a second, please. Just a second. मिली चेक करो ढूंढने को बोला चेक करो कल क्लास रख ले टाइमिंग मैं सुबह बताऊंगा शाम को 4-5 बजे लगे चलेगा चलेगा आज यार नहीं ये मैं क्लास भूल गया था ये तुम्हें बताना कि अच्छा हो गया अच्छा हो यहाँ पर आके रेस्ट किया आपने अच्छा सुन अपने मार्क्स कर ले फिर बताना मार्क्स व्हाट्सएप करके उसको फॉरवर्ड करना बाद में चलो अभी उसको बोला अभी आप दोनों अपने मार्क्स कैलकुलेट कर लो yes hello have you done yes Arav Saksham
Yeah.
Dan have you done Nippon
Yes, sir.
Sparsh
So still
I'm done.
okay I'm sharing my screen with you All of it done? Clear?
Yes.
Okay, now come to this configuration now.
This is 32. The answer.
So, what's the electronic configuration of fluorine?
Fluorine, atomic number is
It will
9,
be 27.
27. Atomic number 9.
Okay, sir.
Okay, now
So the answer for this one is 32.
let us check. Wait. The electronic configuration of dye positive ion is this much. If you add this electrons, it is a 10 plus 14, 24. It means in the metal M, there should be 26 protons, 2 extra electron in the neutral atom with a mass number 56. So the number of neutrons should be equal to 30, not 32.
Yes.
Because
Okay.
you have chosen 24. Actually, metal has atomic number is equal to 26. You are not supposed to remove the protons. You have removed the electrons only to make a dye positive ion. Yes or no?
Yes, sir. Correct.
This you leave this question. Okay.
Nucleus.
Nucleus.
Nucleus, yes.
Isobars.
Good.
Alpha particle.
Leave this question. Not required. E by M value not required. You work upon this question.
First one. First one. So that's the first one.
Yeah, sir, the first.
Okay.
Atomic number.
Atomic number.
Atomic number.
Atomic number.
Good. Uh,
I
no,
don't
you
think.
can't do it right now. I had not taught you the mole concept. After this, I will talk about the mole concept. Do you know about all this? Quantum theory?
No, sir.
No. I need to discuss about it.
No.
So that, yeah.
X-rays.
Sure?
No.
No.
Micro.
Okay, leave this question. I had not discussed this actually. Wait. These all things are not done.
So there are 202 questions.
I had a lot of question bank, but level wise, some question are the grade 11 also. You are on the grade 9 only. I have so much question bank. That is,
Not some many.
yeah. Wait.
So the questions that we did today, could you please like upload it on the?
Sure. I'll send it one good assignment, either in the PPT form or the simple text also. It will be there.
Okay.
It will be there. Not only these, many other will be there.
Yeah.
Leave it. Okay, now work upon this question.
So it's the
The second one.
the second one.
Good.
The CH3 plus.
Carbon has a 6 electron, oxygen has a 8, total are equal to 14.
So it's N2, I think. Yeah, N2.
N2 will have 14, yeah. 7 plus 7, 14. 6 plus 3 is 9 minus 1 is equal to 8 electrons.
Oh, yeah. Sorry.
So what does it mean heavy water, D2O?
Yeah.
I,
When I say water, it means H2O.
yeah, so what
Wait,
does it mean by
I'm
D2O?
coming to it. This is the H2O. If I replace the hydrogen with a deuterium, heavy hydrogen,
It's deuterium oxide.
yeah, it is called a heavy water.
So maybe 20. Not sure.
Okay, what I do is, I have two things here. There are two deuterium atoms,
Yes, it's
right,
20.
and one oxygen here, right? In the deuterium, I have a proton 1, but in 2 it will be 2. Neutrons will be 2, electrons will be 2. Oxygen, protons are 8, neutrons are 8, electrons are 8. You got it? So 24 plus 6, 30. Answer should be 30. Yes or no?
Yes.
If you find difficulty, let me know
Can
now.
you just show it again?
Okay, should I explain it again?
Yes, sir.
Okay,
1 minute.
okay. Wait. I'll show you here. I have a D2O. It means I have a 2 deuterium atoms and 1 oxygen atom. Okay. Deuterium means what? Deuterium means 1H2. It means in one deuterium atom, I have a 1 proton.
But its mass number is 2.
Yeah. 1 proton means a 1, and but in
So,
2
so,
neutron till 2 protons are there.
so if it's 2 deuterium, then the mass should be 4, right?
Yeah, yeah. But I'm not talking.
And
No. I'm not saying this. I have 2 deuterium atom like this. I'll not say like this. I have 2 deuterium atoms are here. In 1 proton, I have 1. Then second proton, so total protons are equal to 1 plus 1, 2. Neutrons are equal to 1 from here and 1 from here. Total neutrons are equal to 2. And electrons in 1 here, 1 here, total electrons are 2. Yes or no?
yes,
Yes, sir.
And in case of oxygen atom, protons are equal to 8, neutrons are equal to 8.
neutrons are 8 and electrons are 8.
So if you add all this, 24 plus 6, 30. 30 total number of nucleons are there. That's what my question here is. My question here is the total number of subatomic particles means what? Proton, neutrons, and electrons.
Okay, sir. Yeah, I got it. I thought I was asking for the mass number, so I got confused.
Today level has increased. Level of learning, teaching increased. Yes or no?
By 50%.
Yeah. See, in the earlier 2 classes, I was
No,
making just the base of the subject, basics that must be strong. And once you have got something, now we must do practice of the questions that is expected in the Olympiad.
all these questions come in the Olympiad?
Such type of questions are there. I will not say this particular. You must have a clear idea, then you can solve it.
Okay.
Right? It's the basics, like you must know this much. Then only you will be able to crack that question there. Okay, come to this question. Wait.
Proton and tritium.
So is it
Proton and tritium.
Proton and tritium.
yeah.
Wait a second.
Yeah.
Wait a second.
Yes, sir.
Just wait a second, please. Could you please just give me a minute only?
Yes.
Sure, sir.
What? Three to four. 3 to 4. 92. 8 minus 8 minus 10. 82. वो छोड़ दो. 8 log वाले नहीं आते. ठीक है. मतलब बहुत अच्छे नंबर नहीं है. मेडिकल कॉलेज के प्रार्थना पढ़ने लायक नहीं हो. सच बता रहा हूँ. थोड़ा सा बिटर वर्ड्स हैं, बट फैक्ट. अपने पीछे पड़ जाओ बायोस्टॉम से. तीनों में नहीं भागोगे तो जीरो हो जाओ. और इवेंट्स फुल लेंथ पेपर और भी आ रहा है एवरी डे. तो यहाँ पर पढ़ेंगे टॉपिक बाय टॉपिक. टेस्टिंग आ सके. 2 बजे मैं मुझे कॉल कर लेना. और क्लास 10 बजे कॉल कर लेना. उसके बाद मैं तुम्हें टाइम बता दूंगा. रखूंगा शाम को 3-4-5. आज तुम्हें पढ़ाया नहीं, लेकिन ये ज़्यादा अच्छा लेसन था. अपना औकात तक आज अच्छे शब्द यूज नहीं कर रहा हूँ सुबह से. Yes, I'm back now. Yes, hello.
Yes, sir.
Yes.
Okay. Enjoying the class? Learning?
Yes, sir.
Yes.
You must learn, and today little bit of brain hammering, huh?
Not really.
Not really.
Really.
Not really.
Okay. But this level must be achieved, at least this much level. Can you see my screen now?
Yes.
Very clearly.
Okay, I was discussing this question. What was your answer?
Proton and
Proton and
tritium.
plutonium.
The proton and tritium.
Proton tritium.
Lightest element. It means I'm talking about the
Hydrogen.
1H1. Protons are 1, neutron 0, electrons are 1. Means the missing is the neutron. Okay. So answer should be neutron.
But it's a fundamental particle.
Fundamental particle are
And,
these.
but a hydrogen atom can exist without a neutron or an electron, but it can't exist without a proton.
See, the question is in that particle, what is the missing fundamental particle? Neutron is missing. Neutron is missing. And it's a protium. I think clear?
Okay, sir.
Do you know their atomic numbers? Do you know their atomic
No,
numbers?
sir.
No.
Not at all.
Scandium 21, 22 for titanium. Manganese is 25. Iron is 26. Cobalt is 27. Copper is 29. Zinc is 30. I am giving you this data. These are the atomic numbers.
I guess it's ABD. So it's A, B, and D.
A, B, and D means third option, you mean?
Yes, sir.
No. Calculate your own. If otherwise, let me know. I will discuss in detail.
Sorry, sir. But, I got a bit confused here. Like, I confused it with isobars.
Isoelectronic.
Yeah, I confused that.
Everybody getting this, or should I explain?
I got it now.
So I got it.
Arab, Nippon.
Sir, can you explain?
Okay, I'll explain. It's just a question of counting only. Just a minute. What is happening? See, scandium, atomic number 21. But to make it 3 positive, it means I have to remove 3 electrons. From the atomic number 21 means from the 21 electrons, I have removed 3 electrons. I'm left with the 18 electrons now. Is this clear? The first step should be very clear. Is that clear? Yes or no?
Yes, sir.
Yes,
Yes.
sir.
Titanium, I told you atomic number is 22. It means that in the neutral atom, there are 22 electrons, out of which I have removed 4 electrons. It means now I have got titanium 4 positive and got 18 electrons now. Manganese, atomic number 25. Remove 2 electrons, it become Mn2 positive, and I'm now left the 23 electrons. Yes or no?
Yes, sir.
Iron 2 positive, atomic number 26. Atomic number 26, out of which I have removed 2 electrons, now left the 24 electrons.
Yes, sir.
Cobalt, atomic number 27. I have removed 3 electrons, 25 electrons now. Zinc, 2 positive, 30, and not 28, 28 electrons now. Zinc atomic number 30. When I make a zinc 2 positive, I'm left with 28 electrons. It means scandium and titanium, these are isoelectronic. So A is correct. What about C? 26, 24 and 24. Same number of electrons. And copper 1 positive and zinc 2 positive. Copper 1 positive, atomic number 29 minus 1, 28. Zinc 2 positive, 28. ACD, correct answer. Manganese and iron, they don't have the same number of electrons. You can see 23, 24.
Yes, sir.
Everyone get it? Got it now?
Yes, sir.
Yes, sir.
If you find difficulty, let me know. I can explain it.
So the third one is wrong.
Hmm?
Third one is wrong.
Third one is no wrong.
No, wait, sorry. I thought it said, my bad. It's not wrong.
Second option is wrong.
Yeah. I thought it
Some
said,
it cannot have
I
18
thought it
protons.
said all naturally occurring
Yeah, yeah.
contain 20 neutrons. So.
Leave this. I have not explained all this. Yes. Now work upon this.
The He plus.
No,
No,
H.
it is He,
See, it is a hydride with H negative.
which
It is
means
now I have an electron. Yeah.
and helium atom has 2 electrons.
Yes, yes. Got it now? If I say hydronium ion, that would be H positive, and that would have a 0 electrons. Okay. Okay, now similar type of question that we had done earlier also.
I think it's option number 2.
Yeah, yeah. 2 positive ions are there, so it means double of this charge. Everyone got
Yes,
this?
option 2. Yes.
This I have not to teach you right now. Okay. No, not required.
First, in your question bank, it asks like questions from different grades, like 9th, 10th, 11th, 8th.
See, atomic structure is very briefly discussed in grade 9, but in very much detail in grade 11. So these questions are basically from the grade 11 also,
Okay.
right? So it is a let me check what is the maximum level I can teach you. You will be able to understand. Or what is the requirement actually? Right, requirement is up to your standard only, but I'll segregate my questions. So leave this question. No, we
The
can't.
level 3 means like how?
Level of the question has increased. You might have seen that the level 1 and level 2 electrons, level 2 questions, there is little bit more difficult than level 2. So, so I have just segregated my question according to the need, like easy question, then more difficult and more difficult. That is level 1, level 2, level 3. Okay, fine. Just wait a minute. Okay, I will now teach you something about the mole concept. Brief introduction about mole so that you can understand in my next class better.
But moles is in the next chapter of chemistry, no?
See, when we come to in next chapter, you mean?
Yes, sir.
Yeah. Actually, when the question come in Olympiad, it does not come from any one chapter. That question is designed in such a way that it include 2 or 3 chapters. right? That's what you can see in my different questions. In the atomic structure, mole concept is being used. So it will be including 2 or 3 chapters all together, and they will frame one question. So I'm just connecting the mole concept to the atomic structure now. I'm going to next level now. Okay, the simple things I have told you, that is given in your book, but when the Olympiad question come, it is a bit higher level. Wait. Okay. Today was like the level of the question was bit higher. Yes or no? In the
Yes,
previous
sir.
as compared to, and in the previous 2 sessions we have discussed the basics, and today we have applied it. In the Olympiad, basically the application question will come. Application questions means whatever you have learned, that will be applied in some questions, that will be used. Okay, now what is 1 mole, right? That is a concept. Okay, to understand the concept of a mole, can you tell me how many articles are there, how many entities are there in 1 dozen?
Well,
So can you just repeat?
I repeat, if I say I have 1 dozen bananas, then how many bananas will be there?
So 12.
12. 1 dozen pen, 1 dozen chocolate, 1 dozen computers, 1 dozen bottle, anything. Whenever say 1 dozen, that simply stand for
12.
12. It means 1 dozen is a word that is representing 12 entities. That is representing 12 entities. Right?
yes, sir.
When I say one pair, P-A-I-R, how many entities will be there?
2.
2.
With
A
one
pair,
pair of shoes, 2 shoes will be there.
yeah, yes. So one pair of anything, that will be equal to 2. Century,
100.
100. Good. 100. Similarly, in chemistry, I have a word MOLE, mole. That shows a number 6.022 into 10 to the power 23. Okay. 1 mole is equal to 6.022 into 10 power 23. This number is called Avogadro's number. This number is called Avogadro's number. It is denoted by Na. It means I will not be writing this number again and again. That will be Na. Getting me?
Yes.
Yes or no?
Yes, sir.
No. This number is a very big number. How much big? If I write 6022 into 10 to the power 20, will that be okay if I just remove the decimal place from here?
Yes.
Can I say I need to put here 20 zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Almost the mass of Earth.
Huh?
Mass of Earth.
Can you read this in words?
No, so impossible.
Right? Unit, 10, 100, 1000, 10,000, 1 lakh, 10 lakh,
Crore.
1 crore, 10 crore, 1
crore.
Arab, 10 Arab. Next what?
We'll have to see Google.
Then actually Google will also not tell you something. Right? Where common counting stops, our counting starts. We are talking about very small numbers. We're talking about very, very small numbers. That is,
Sir, after Arab, 10 Arab, then Karab, 10 Karab, then
Hmm.
Nil, 10 Nil, Padma, 10 Padma,
Hmm.
Chunk. It's like that.
Okay. Still, it is not going up to that level.
Then, sir, after that, 10 Chunk, then 1 Smudra, 10 Smudra, 1 Antia, 10 Antia.
Okay. Some Sanskrit has come in. Okay.
Yes, sir.
I understand. Okay. It means we're talking about a very big number, right? How much big is the number if you put the 1 rupee coin? You have seen the 1 rupee coin?
Yes, sir.
If you place the 1 rupee coin one above the another like this,
Yes, sir.
from the surface of the earth, you will get 2 pillars.
Yes, sir.
That much is a big number. Okay. So
Yes, sir.
that much is the big number, right?
Yes, sir.
Okay. Suppose this is okay. Sparsh, I'm going to ask you. I'm going to ask you one simple question to all of you. Right now, you're in ninth standard,
Yes.
right? And I think that now you have realized. Now you have realized, or that after some years you have to come into some profession,
Yes, sir.
so that you can earn money.
Yes, sir.
Yes or no? Yes or no? Till
True.
eighth class, I think we learn only because others are learning. Some others are going to school. That's also we are going to school,
Yes.
right? We are just enjoying the school. That's it. But when you come in the 8th standard, 9th standard, then we realize the real picture of the world, that after some years you have to earn some money. Yes or no?
Yes, sir.
Okay. So after, let it be another 7 or 8 years.
Yes.
7 or 8 years. So what do you think your first salary should be? After, let it be after 8 years, you're entering into some
So
profession.
I plan to teach for my first income.
How much your should be your first salary?
Sir, at the salary of Amazon.
Salary of?
Salary of the CEO of Amazon.
What is that salary?
That's like almost,
So he earns like $100,000 each second.
yeah.
Okay.
I
Okay.
was calculating that only.
Okay.
For me, I think per salary should be around $150,000.
Okay.
Everyone is having high expectations.
If you compare with my number that I gave you, is it less than that or more than that? The number that I gave you,
That,
Avogadro's number.
less than that.
Your number is
It's far
less.
less.
Your number is less. Right? Okay. So the same question was asked to me when I was in grade 11 actually. I was taught about this small concept in detail. So I was asked this question, what should be the first salary? I just told that this much salary means 1 mole of rupees only per month. 1 mole of rupees only per month will be the salary of my PN.
The
You got it?
salary of your what?
My PN, my assistant, my PN will be there. One who comes with me. He brings tea with me, tea for me, water for me, right? So that will be salary of my PN, and what would be my salary? I don't. You can calculate. Anyways, so it's a very big number, right? If you
Yes.
if you start spending it 10 lakh rupees a second, you will need 12,000 years. Right. Anyways, I'm talking about a very big number, and because my particles are very small and counting is too big. So
Yes.
we'll be now going into in detail next class, right, about all this mole concept and all. And by that time, sending you one assignment, work up on it, right?
Sure, sir.
So I'm ending the session now, and see you next week, and enjoy with the mole big number. Okay then.
So
Sure.
thanks
Goodbye for
sending
now.
the assignment.
Okay then.
Thank you, sir.
Thank you, sir. Bye.
Goodbye.
Bye,
Thanks,
sir.
bye.
Bye.
So where are you sending the assignment, you said?
Most probably by tomorrow I'll be sending it, right?
No, but where? Where?
I think on the platform only in the assignment.
Oh, okay, okay.
Okay.
Hello.
Hello.
Hello. Am I audible?
Yes, you are audible. Okay, can you see my screen?
Yeah, I can see your screen.
Okay. We were discussing
Wait,
about
one.
amines, right?
It went black. Your screen went black all of a sudden. And now I can see it. Yes. Now. Yeah.
Not okay
Yeah. Now
now?
you. Now you stop sharing. Yes.
Okay. Now, again, I'm sharing.
Fine.
Now I can
Yeah.
see.
Now I can see it. Now I can see it. Yes.
Okay.
Yeah. Could we start CQs for amines? Because
Yeah. I hope the chapter is over at your school level, right?
yeah, it's over. It's over.
So we can now directly jump over to
Yeah.
the right MCQs.
Yes.
We had done last some questions also, right?
Yeah. Yes.
Okay. Amines objective. Just a second, please. Just a second, please.
Yeah. Yeah. Of course. Sure.